Right. Well, hey everybody, it's BIM Broadcast here. Shawn with CAD Technology Center, technical evangelist over here, and we're going to be sitting down today and talking to you all about, talking with you all, because you can feel free to join us in live chat, talking with you about laser scanning, capturing as-built, capturing construction progress and all that jazz. And we're going to be joined today by Kelly Cohn from ClearEdge. And we'll be talking through some of this stuff. Now, I do want to make something clear here. The live feed on YouTube is being watched. Don't be shy. Feel free to add to the conversation. It does make things more interesting when you chime in. So definitely jump in there. First thing I'm going to talk about today, and I'm going to jump over to a different screen here. Let's take a look at some new tech that was introduced to me actually by Kelly. Some of you may know about this, but if you don't, I know a lot of you have multiple computer stations next to you, multiple monitors, things like that. And, you know, we all struggle switching between. Some of us have multiple keyboards and mice on our desk. Some of us have KVM switches, and sometimes it's just frustrating. There's this new thing, and why am I not seeing you, Kelly? I don't see you on my screen, and that was not expected. Let's get this pulled back up.
They totally missed my really cheesy wave.
Hey, there you, they did. They missed you. So now we got you up on screen here. All right. So Kelly Cohn, everybody. We were talking about this, and Kelly is using this cool tech by Logitech. It's moderately newish. It's called Logitech Flow. And Logitech Flow is a software situation here that lets you kind of combine multiple PCs, multiple workstations or virtual systems together and automatically take your mouse and your keyboard settings and as you move across your screen, it automatically like transitions to the other PC, which is really freaking cool. And in reading about it, you can also do really slick things like grabbing a file from one computer and drag it across to the other monitor, to the other computer, and it automatically manages that file system. So it copies it across or moves it across. And that's like cool stuff. So those of you who are working with multiple computers, you might want to take a look here at Logitech Flow. It does require specific hardware. Okay, that means specific keyboard and mouse. Like I was looking at it, I have the gaming series G19 keyboard and the G whatever this is. It's a G602 mouse, and it does not support that unfortunately. But you know what? Hey, you can upgrade your hardware at the same time and get a cool new keyboard and mouse to kind of go along with the system if you're interested in that. Now, CTC and BIM Broadcast isn't sponsored by Logitech. I don't know if Kelly Cohn is, but I know we are not. So, but we like to share with you cool tech that we like to work with.
But I am open to options, Logitech, if you're listening.
Yeah, Logitech. Hey, so Logitech, I'm using your keyboard, your mouse, your camera, a microphone from you guys. So just saying, sponsorships are not to be denied. Anyway, all right, let's get on to talking with Kelly about some stuff. So let's see here. Kelly, you work with ClearEdge, right? That's your company name?
Yes, guilty as charged.
Guilty as charged. Now, before we start talking about what ClearEdge is and what they do, let's talk a little bit about you so the viewers can know who we have on the phone today. You got your start in architecture how? Where did you kind of start in industry?
I actually went to school for it. Spent 6 years getting 2 architecture degrees at the University of Texas at Austin.
Nice.
You know, because 5 wasn't enough.
Well, no. You got to go for more years is more better.
Yeah, absolutely. It's more fun.
Yeah, it's just more.
So yeah, I agree with that. It was more, more to the pocketbook,
more expensive. Yep, more time.
Yeah, but no, did that, and then wanted to get up to the Dallas area for family reasons. And just happened to find a really great firm up there called the Beck Group, which was an architecture firm and a construction firm, which I was kind of jazzed about because I liked building things and spent some time in the trades prior. And so, yeah, it just seemed like a really good fit and ended up staying there for 10 years. So I guess the shoe fit pretty well.
Awesome. So you did architecture and then you moved over into construction, right?
Yeah. So I spent probably 4 or 5 years on the architecture side of the business, starting out in design and then running the Revit implementation for the company nationwide for a couple years. And but had really wanted to spend some time in construction. And
Yeah.
towards the end of that, was doing some stuff in the pre-con department, and then managed to get out on the Kimball Art Museum Renzo Piano Pavilion expansion
Nice.
as a construction job, and so spent about a year and a half working on that project in the trailer,
Yeah.
which was a blast.
That sounds like a really good entry level, construction management job.
Yeah, it was really rough. I mean, that being said, those jobs are also the high stress
Oh yeah.
and
Yeah.
high demand jobs. But
Yeah.
it was, particularly coming from an architecture background, getting to work with RPBW was pretty fantastic.
Awesome.
And yeah, then came off of that, came back into the office and kind of basically started running the virtual design and construction team for the company. And that's what I did for the last probably about 4 years there. So
Awesome. Now in that that adventure, you guys were transitioning from AutoCAD over to Revit, right?
yeah, initially, yeah, that was the second through fourth year of my professional career.
Nice. That's a fun adventure.
yeah, it's a fun adventure. I learned a lot doing that. Also learned how to do it a lot better because we went through about 4 other different software implementations after Revit. So I got to appreciate all the things I did wrong the first time.
Well, it's always a learning experience. It's a practice after all. People practice architecture just like they practice medicine and law and whatever else. So it's all about practicing.
If only our hourly rates were as high, though.
That, I believe, is the fault of the architects.
Yeah, there's some self-inflicted punishment there, no doubt.
Yeah, exactly. So when you went to the construction side, that was when you kind of started digging into what we're talking about today, which is the point management, point scanning, things like that, right?
Yeah, we and actually, it's kind of the first job that we did was a architecture project where we needed to document as built, and so that was actually before Kimball. But we hired somebody; they came in, did all the scanning, gave us the data. We generated some models from it for documentation. It was a really interesting experience. And so that kind of put it in my head as a possibility. And then out on Kimball, we did actually quite a lot of scanning on that job, doing different types of quality control workflows and just tried to support the coordination process. And that's really where it kind of came home in terms of it not just being a really cool, interesting technology, but really, really understanding that it has a lot of broad applications within the AEC space. It's not just a as-built tool or something like that.
So what were some of the lessons you guys learned in that first as-built workflow?
It's hard to model from scans.
No.
Yeah, it's there's one of the concepts we talk about a lot at ClearEdge is the difference between CAD and kind of what we call CAB, which is not something you use to get home after a long night of drinking. But CAD being computer-aided design and CAB being computer-aided as-built.
Right.
And the big difference, of course, being accurately representing real-world conditions. And CAD systems are really built upon this conceit that the world has sprung from the brow of the designer, right?
Well, we all know, just talking with my civil side, my civil team, that architects are of the opinion or persuasion that the entire world and all of its coordinate systems revolve around A1, level 1 on a building.
Well, I mean that's the one building you're working on right then.
Right. So the whole world revolves around just that. That's the way it goes. Yeah.
What else matters?
Right. Nothing.
Yeah, so I mean, the coordinate systems are definitely a part of it, but it's just, nothing actually gets built plumb. Nothing actually gets built orthogonal. Nothing actually gets built, perfectly. So the challenge is, when you're dealing with laser scanning, which documents and captures things very accurately, is how do you manage that migration from a extremely accurate representation in the point cloud to a kind of fundamentally abstracted and inaccurate to an extent representation in whatever your CAD package is or
Right.
BIM package. And so that's 90% of the problems are correctly handling that translation, if
Yep.
you will. And it really is almost like a translation from one language to another.
Oh, yeah,
So,
absolutely. I mean, it's two completely different sets of data. One is the almost napkin sketch theoretical, CAD hardline drawing versus the real world. So, I mean, they are two different languages. So, in your first project, how did you guys mitigate that? I mean, you brought in your point scans. You were using what at the time? That was Revit, right?
oh yes, but this was before Revit had point clouds in it. So
Right?
no, actually, this job was like, it was a dream. Let me tell you. So we had everything modeled in Revit. We cranked it over to Navisworks,
Mhm.
and then we loaded the scan into Navisworks, and then we went through and we looked at everything in Navisworks. And so on one screen we'd have Navisworks open, right, with the point cloud and the model overlaid, and
Yep.
then on the other screen we'd have Revit. And then
Uh-huh.
we'd be like, "Oh, that doesn't line up well," and we'd nudge it over,
And then
re-export to
save and
Navis,
re-export and reload. Oh my
and then
gosh.
refresh. Okay, that looks pretty good now.
I
You know,
like
you
it. I like it.
take a little measurement in Navisworks. Oh, we need to
Uh-huh.
move
Uh-huh.
that over, 7/32 of an inch. Okay, well, let's only do it, an eighth.
Yeah, yeah.
Um, but yeah, so I mean, it was a really tedious, painful process, but it was important
Well,
for
yeah,
the
it's a
job,
great learning experience. And it kind of got you a bit to where you are today.
no doubt.
Yeah.
That
So,
was, yeah, that's where I actually that project was when I first heard about ClearEdge 3D, because we were having so many problems doing this that we started researching. All right, is there anything that makes this easier?
right.
Uh, so
So let's talk about ClearEdge and ClearEdge 3D specifically, the company. Now, you guys do two different major things. You do point scan to model conversion, and you do as built to as modeled validation. Two different things, right?
yes.
So let's talk first about the scan to BIM kind of process. What does that look like?
So, I think most people probably that have worked with scan data, at least in the last couple of years, have probably seen some of the extraction tools that are on the market. So, fundamentally, it's a pretty understandable process. It's what you would go through if you were doing it manually, right? Which
Mm-hmm.
is, you kind of look at the point cloud data, spin it around, look at it a couple different ways, take some measurements to figure out what the diameter of a cylinder is, and then try and model that cylinder and adjust the endpoints until you get it to actually line up
Right.
visually as best you can.
Yep.
So the extraction tools, shortcut most of that workflow. You kind of window box around the points, and these extraction tools will then do an optimized best fit set of measurements against those points to basically do all that work for you, which is really nice.
Very
So there's a
nice.
lot of great tools that do this. Most of the registration tools like Cyclone or Scene or Collage or RealWorks, they have these extraction tools in them. There's a great plugin for Revit called Scan to BIM that has these kind of extraction tools in them. That's by Imagineit. What really sets us apart is that we apply a lot of computer vision algorithms, which is a fancy sounding thing, um, and it's kind of like machine learning.
Machine learning, right?
It sounds really fancy and sexy, right?
Right, right.
Computer vision, which is really a way of saying we try and teach a computer to do what you or I can do when we look at something.
Right,
This is how Google knows that a photo has a cat in it, for instance.
right.
So what we will do is actually automatically parse the entire point cloud, looking for cylinders, looking for certain things, and then automatically generate those points. So we eliminate that having to go around and window box all the pipes step as well.
Right.
So that's how our piping tool works. You basically run some processing, you go, sleep for the evening on a big job, or you go grab lunch. on a smaller job, and you come back and 80 to 90% of your pipes are just modeled for you, which is not a bad starting point compared to starting from scratch.
Yeah.
Structure,
Yeah.
we do pattern extraction, so you kind of define the initial pattern, and then it replicates through the rest of the kind of project or the bay or the direction. So we really kind of focus in that product on highly automatable tasks, because our goal is to get you as much as you can very accurately, very quickly. And we give you some tools to kind of manage that as built to CAD translation. So we have tools to snap things parallel, snap things level, snap, et cetera. And then we have plugins into Revit or Plant 3D or PDMS, different authoring tools.
Right.
And we basically redraw all of the geometry natively in those applications. Because those applications don't deal with geometry imports very well, as we all know.
Right. So it can be an immense time savings over the manual drafting process of this.
Huge. So, I mean, most of the people, if you can look at our website, see the customer, the customer reviews. Of course, we choose those because they're good ones. But
we're in the world of a bit of marketing, so we want to make sure we provide you, the end user, with the best possible experience. We'll talk more about that later.
Yeah.
but yeah, the reviews, obviously they can speak for themselves to a large degree. So
80% workflow man-hour savings are pretty common in piping, 80% in structure. So yeah, if you're doing any kind of scan to BIM stuff regularly, it's a world different from manual extraction or, God forbid, manual modeling.
Yeah. So you first got introduced to this back when you were at Beck, right? When you were doing the as-built stuff, and your first project you guys did completely manually, I think you said. And then in the future, you guys found out about ClearEdge 3D, and you got the opportunity to kind of use that. And what did that do for you guys at Beck? Like specifically, you said 80%. That's just kind of some of the customer reviews. What was it for you guys in your first round?
So, it's just so long ago. I'm not even sure I remember. We didn't use it on every job, because not every job is one that even makes sense to do it. But because a lot of the stuff that we were doing was also construction QA centric at the time, and ClearEdge did not at the time make a software that would solve that problem. But when we were trying to generate a model from a point cloud for an as-built for our architecture department, particularly if there were mechanical spaces and things like that, it's just, there's not a better way to rapidly get a mechanical, kind of the mechanical scope of work represented. And the structural tools are pretty recent, so that's only within the last year or two that's really been in the product. So it's constantly evolving. But back then we would use it on big piping jobs, because that's what it was really, really good at.
Oh yeah, man, measuring piping in the field by hand is ridiculous too. Man, that's rough. It's not. Good Lord. So let's talk about the capture process, right? Like you're talking about a software solution after the capture has taken place. But let's back this up a step. Some of the people that are probably going to watch this, either watching live or will watch in the future, they may not be familiar with the world of scanning, what this actually means. So let's back this up for their benefit and talk about how does this process actually flow. So we're going to talk about a couple things here. How does it actually flow? What tools are used, and what does it take to get into this? So we'll take it one step at a time. What does the flow look like from you starting this process of an as-built going into an actual model in Revit? How does that go?
Yeah, so I mean, there's some kind of critical steps up front. I mean, if you're high level, you're talking about capture,
right?
There's a kind of registration process. There's a cleaning process, and then there's really kind of a importing it into the BIM application process, and then from there, you've got your kind of typical modeling workflows. So
let's start with capture. Like the capture process here, you have to go out in the field, and there's a number of ways you could capture. Some better than others. Many of us have heard of like aerial drone scanning, right? Like we do a lot of site scans at CTC. We have a team that does this. We fly around sites and do quick captures to see what's new, and that's one way of capturing stuff. There's other types of things like laser scanners, and there's a huge variety in that environment of what they can do there. And I know that's where you guys kind of specialize, right? Is in the laser scanning side.
Yeah, so
consuming that data.
Yeah, reality capture kind of as a whole is a pretty broad term.
Right.
So, it's easy to classify also a lot of the different sensors. Like on Kimball, we were using sensors embedded in the concrete to measure moisture content and cure. That's reality capture. We were
Right.
capturing real information, digitizing it, and then being able to utilize that for different decisions. So, specifically though, to this kind of visual measurement and capture space, yeah, the photogrammetry is a big one because taking photos is cheap. The
Right.
hardware to take photos is cheap,
Right.
and everything is basically constructed from overlap and alignment. So once you have two photos aligned, you can identify the same pixel in both photos. Project it out, you have an XYZ coordinate. So photogrammetry is a really good solution for kind of 3D measuring, but primarily has been in the kind of survey, the geographic space. And so there's some kind of core weaknesses with that within the built environment because we have a lot of repetitive patterns, which photogrammetry solutions don't like.
Right.
And we have a lot of flat, single, monolithic surfaces, which they also don't like. So, but later we can talk about some of the innovations in that space that are trying to solve those problems. But,
Yep.
laser scanning is, those are passive solutions, right? The photogrammetry is a passive solution. Laser scanning is an active solution where you're projecting the light out that you're using to take the measurement. So,
Right.
they basically it's just think of it as a highly accurate laser disto that's spinning around really quickly and taking lots of measurements. Modern scanners will take anywhere between 500,000 and a million measurements per second.
Right.
So lots of measurements.
Significantly faster, you'd say, than maybe I could in the field.
Just a little,
Just a little bit faster, yeah.
Yeah, and they tend to be 360, 270. So it's a highly accurate 360 measurement solution.
Right.
There's two types of laser scanners in a broad class. There's terrestrial, which are things that sit on tripods, and then there are mobile, which are things that move as they scan, which can technically be the same hardware. But if it's stationary when it's scanning, it's terrestrial. If it's moving, it's mobile. And we primarily focus on terrestrial scan data because it's been around the longest, it's the highest accuracy, and there are some standard formats, which when you're a small startup, it's nice to have standard formats because you don't have to write 37 different importers. And so, but we are starting to leverage mobile data. We've actually we'll have a kind of an alpha or early beta announcement at AU with a partner of ours, GeoSlam, with their mobile scanner, and we'll be able to leverage that data in Verity, which is the application we didn't talk about a minute ago.
Right. Yes, we'll get to that one, but. Yeah, GeoSlam is actually, I was reading through this technology. This thing is freaking cool. You basically put on a backpack, you have a handheld scanner, you walk around, and it captures as you walk while you're kind of walking around the building, either way. So you were mentioning that you guys have partnership. I believe it's up on your website there. That's the ClearEdge website, guys, so clearedge3d.com. And you kind of have a pre-announcement here of some of that stuff going on with that scanner. You can kind of see the scanner kind of in action here, backpack device with a handheld deal, and those are pretty darned accurate, eh?
Yeah, there's this wonderful acronym called SLAM, GeoSlam. It's called Simultaneous Localization and Mapping, and they basically have some really sophisticated algorithms that are figuring out as you move around how to track that scan head using a variety of different inputs. So there have been some pretty impressive test results, and there's some other companies that do similar things. There's a Jexel, there's Leica has their own mobile solutions. Trimble has the Thames card. So everybody's kind of getting into this space, but the benefit of mobile solutions is that the registration part of that workflow. So you capture. If you do terrestrial scans, you have all these individual locations, and now you have to line them up to each other to get an overall 3D model, because these things don't see through walls. They don't capture. It's just what you can see from the scanner location, it can see.
Right.
And so you have to register these things together in a very accurate way so that your overall laser scan is accurate.
So kind of like with the whole idea of photogrammetry, where there's overlaps in photos, there's going to be, hopefully, ideally, necessary overlaps in the point data.
Yeah, unless you're doing everything on survey control and each scan location is surveyed in, which is a very valid workflow,
Hmm.
but not typically very relevant for an interior space
Right.
for every single location.
That's a
But
bit more common when you're doing like site surveying, where you can actually get
road work,
geolocation more easily,
civil,
satellite
those kind
signals
of
and whatnot.
things.
Yeah. Yep.
So yeah, I mean, basically, that's registration though. That's the hardest part of the workflow right now.
Right.
So capture is pretty easy. Um, Cleaning is pretty easy. The modeling is,
Now
while
really easy
well, with our solution,
with
really
your
easy. That
solution.
while tedious if you're doing it manually, is at least I think a pretty well understood task.
Right.
But the registration really does. There's still a bit of an art and to doing a good registration with terrestrial data. Mobile solutions, that's what SLAM does. It's all kind of registered when it's done. So, the beauty of the GeoSLAM stuff is, right, you go out there, walk around the site with this thing, and you walk back into the office, and it's registered, and you're ready to
Nice.
use it. And so
Yeah.
it's, we're pretty excited about it. It kind of shortens the time to analysis in our software
Yeah.
because you kind of eliminate an entire step. And our software, at least on the Verity side, does not really require any cleaning. So you don't really need to do that either. So it's pretty much
Very nice.
capture, register, analyze, but with GeoSLAM, it's just capture, analyze. So, we
Yep.
like that.
So, I mean, we've talked about what you guys do a bit. We've talked about what you did over at Beck. What are you seeing as a trend in industry overall for how people are doing stuff like the as-built type process, where they're capturing a building? What are you seeing there? Are they still doing tape measure in notebooks, or are they, the old analog method? Or are they using laser scanning more frequently nowadays, or what are you kind of seeing trending?
Yeah, I mean, I think there's no doubt that laser scanning is trending upward and pretty fast.
Right.
Yeah, my general experience from doing this at Beck, we had a team of people on the VDC team there that were doing scan to BIM workflows for in support of both architecture and construction. By the time I left, so it went from the occasional job to pretty much every job that was
Right.
a renovation or needed some level of QA. It was being scanned, and it seems like if you haven't used scanning on a job before, you're a little suspicious about it
Hmm.
because you don't know. But
Like any new
should,
technology.
like any new technology, but pretty much every job that we used it on, by the time we got through the first real deliverable, it almost immediately switched over to we were just getting phone calls. Hey, I've got this problem. Can we scan it?
Right.
Because it's such a compelling, easy to understand, thorough mechanism for solving as-built problems, quality problems that it makes sense. So it seems like the hurdle is just getting somebody that hasn't used it to do it. Once they
Right.
have, they really don't want to do jobs without it anymore.
Right. Right.
So it's just you just got to kind of get through that within a firm, and then that firm kind of takes off. Then you have another firm, and it's trending up, and that certainly isn't hurt by the price point. So
Right.
3 years ago, when we bought our scanner at Beck, that was roughly $150,000 investment for the hardware and the software.
Beck's got deep pockets. It's no big deal, right?
I, I cannot tell you how hard it was to get budget for that.
Right? No joke. No joke. I mean,
But
large and small companies, that's a hurdle. But you're saying price points coming down now.
yeah, because now that same quality of data, and it can be had for basically about 15,000.
That's not bad by
So
comparison.
knock off a zero. That's
Right.
pretty good over three
Right.
years.
Yeah, absolutely.
So that helps a lot, and we've seen a lot of firms buy Leica's new BLK.
Mhm.
Architecture firms, construction firms are out there buying them because it's so affordable, and they're able to pull that in. It's pretty easy to use too, and just start implementing on workflows very
Yeah.
quickly. So that's something we're excited about because that's a lot more potential customers for our software.
Yeah, absolutely.
Um, and it's funny, we've kind of, when we hear somebody's got a BLK, they tweet about it or something, I'll usually, if I see it, I'll follow up like a week or two later, and inevitably they're like, oh my god, it's so hard to get a model. And I'm like, well,
Well, we got a tool for you that might be able to help you out a little bit here and there.
yeah, yeah. And so it's
Yeah,
it's I think we're excited about it for selfish reasons, but I
right.
think it's a really good thing for the industry because it just the, too often innovations are very slow to make it into the AEC industry.
Right,
And
right.
this is one that's just, we've been lucky that we're kind of on the front of the leading edge of the technology. Um, and so we're really getting to take advantage of this early rather than, having to wait 10 years before, we get a hold of it. So,
Right, right. Well, very good. So, a firm getting into the whole BIM scan to BIM type workflow these days, and I'm using that term scan to BIM, even though there's technically a tool name with that name out there. It is the workflow, scanning and then bringing it into a BIM workflow. Um,
right.
People getting into this, what would you recommend to them to kind of get their feet wet, getting in the door? Because, like you said, there's the whole registration process is a bit of a bear when you don't know how to do it. So how do I, Joe Architect, get started, or Joe, project manager on a construction site, get started on this process?
And the good news is there's a lot of really great service providers out there. So, because the investment was so large for so long, it was something that typically got outsourced.
Right.
So, um, you know, a lot of surveying companies that architecture and engineering firms and contractors already work with provide scanning services.
Mm-hmm.
And there are a lot of specialty shops that really focus on, for instance, the architectural industry.
Right.
Um, and it's one of those things where that's how Beck got started with it. We
Right.
had a couple jobs, we hired people to come do it, kind of learned as much as we could about it, and then we got our own unit and spent another year learning
Oh yeah.
until we got pretty good at it.
Yep.
So
Yep.
that's it's just kind of the process, but it's you know I would strongly recommend reaching out to some of those people that are providing the service, have them do it on a job, kind
Mm-hmm.
of follow them around, see what they're doing, and use them until you're ready to pull that trigger and do it yourself.
Yeah, I know in the
Um,
Midwest area, Minnesota Midwest area, our company CTC has a division that does laser scanning because our clients, like you said, the price point's high, so who could afford it at the time? So we got in and we started doing that as well, so that we could offer it as a
yeah.
service to our clients, so they can get their feet wet, get in the door, and really gain the values on that. So
Absolutely, and
yeah,
there's also a good professional organization. If people haven't heard about it, the USIBD, U.S. Institute of Building Documentation, which is a really good resource. They've got RFP templates. So if you're an architecture, engineering, construction firm, and you want to hire this as a service, but you don't know how to ask for it, they've got a template for you that'll kind of
right.
help you walk through that. They've got a level of accuracy LOA specification that's kind of vaguely reminiscent of the LOD specification from
Mm-hmm.
BIM Forum.
Yep.
And that LOA specification is a great way to kind of walk through and document what you need, so that the scanning provider gets you what you need. Uh,
Exactly. Yep.
and
Yep.
so yeah, that's a really great resource. I strongly recommend people, if you're providing scanning services and you haven't heard of them, shame on you,
Right.
and get involved. But if you're looking to procure them, it's a great resource. So
Yep. Absolutely. Absolutely. So, let's talk about getting scan data in the first place. This is one of the things that you and I kind of talked about pre-show earlier this week. We were talking about, what makes for a good scan to bring into a tool. Now, if you're using something like the GeoSlam backpack walking around, the rules are a little different, but and actually they're not really that much different. They're kind of the same rules. But let's talk about sort of a terrestrial, sort of stationary scan process. You were saying there's some guidelines that you would give people about doing scanning. What did you learn about that?
yeah, so the most important thing to remember with a laser scanner, a terrestrial scanner, is that it's with any of them, it's line of sight.
Mm-hmm.
So if you can't see it, the scanner can't see it.
Right.
And the thing that seems to cause the most problems for people when they're first getting into scanning is shadowing.
Right.
So the easiest way to say that is, if you think about the 3D space, if you're standing in one location and you modeled everything you could see in that location, and then you step away from that location, there's going to be a lot of stuff that you couldn't see. There's going to be the floor under the table. There's going to
Right.
be, the walls inside the vestibule. There's all these kinds of things that are, obscured, basically line of sight obscured. And this has a big impact on scanning, because the whole value proposition of scanning, right, is that it captures everything. And
that
so
it can see.
Exactly. And that's the asterisk. And so,
Right.
the one of the tips that I would tell people is set the scanner at eye level as so your tripod tall enough so that the laser is basically at eye level for you.
Right.
Yeah. So if you're a short person, it's going to be a shorter tripod height. If you're a tall person, it's going to be taller.
But that's okay, because it sees what you
Because
see.
there's not like an optimal height to scan at, but the thing that makes it optimal is just kind of naturally, when you're walking around a space trying to understand it, you move around and look at things from different angles so that you get better understanding of the space, right? So if the scanner's at the same height as you, it's easy to kind of abstract that thought and think about what can the scanner see. If it's rolling around on a cart at knee height, that has a big impact on shadows, because tables, chairs, and things cast a huge shadow from your knee.
Right.
So having that thing up kind of at eye level just makes it naturally easier for people to manage that if they're not used to thinking about it. And then,
Right.
if you can't see it and you need to get low, then you realize I need to set the scanner low. Or if you
Right.
can't see it and you need the scanner high because it's over a wall, a half height wall or something. It's just kind of a natural way to get people to think about it from their own kind of internal perspective. So
Basically,
that's
treat the camera, the scanner, like you would yourself. If you need to crouch, stand, or get up on a ladder, same concepts with a scanner to get the best possible line of sight.
Exactly. So that's
awesome.
that's a nice, easy tip. But and then always, it's easier to overscan and not have to go back later than it is to underscan and have to go back later.
Well, and
Uh,
that's primarily because of the whole registration process, right? You go out there and scan the first time, and you're like, oh, I have got some data. Then you go, oh shoot, I messed this up. How do you re-register that when you get back? Now, there's ways of doing that, but like you said, it's just easier to get into a space and do more in that time than less. It's always better to have more. Like more years in college, right? Like that's better.
Keep telling yourself that. I gave up long ago.
Yeah.
But yeah, I mean, it's expensive to make additional trips to the site.
Yep.
And if something is shadowed and you can't see it, you have to find an alternate way of getting that data or go back. So, same thing with registration, right? If you don't have enough overlap, that you can leverage cloud to cloud to help tighten up your scan registration, then the option's off the table. You got to live with your target or your survey registration, even if there's a slight error in it. So it's always good to overscan, because it's really, really easy to eliminate data that you don't need. It's really hard to generate data that you do.
Right. Now let's we're going to come back to that registration topic here in a moment, but let's take another step backwards here and talk about what else we should talk about with firms when they're trying to implement a new technology in general, but especially the whole scanning process here. I think you were talking about an execution plan, just like you would do when you're kicking off a project in Revit. You want to have an execution plan. So when you're kicking off a project with laser scanning, same concept, right?
Yeah. So I mean, it's not original, but I love the phrase that failing to plan is planning to fail.
Exactly.
And I think no truer words have ever been said. It's I say this also about implementation. So the thing I learned about my Revit implementation, which was largely unplanned for the first 2 years, kind of put out fires where they are.
Right.
But I'm a big believer in implementation plans at kind of all levels of the spectrum. So if you're thinking about buying a scanner, you should put together a long-term implementation plan so you can justify your budget, so that you really know what's involved. Are you going to need to hire a full-time person to do the registration and processing? Are you, just think through those things so you really understand what you're getting into. And at the project level, at VEC, one of the guys there who ran the scanning team, Sylvie Stoyan. So shout out to Sylvie if he's listening in.
Nice.
Sylvie kind of got into this habit of basically bringing whatever material we had into Revit, and actually he made a little scanner family that had kind of radius and different sets, so you could kind of do all your settings.
Yeah.
And
That's
basically he would
genius.
go through and place all of the scan locations that he would think he would need.
Mm-hmm.
And you could do kind of the scan dome would kind of have a color to it, and so you could see your overlap pretty visually just by setting a highly transparent material. The darker the color, the more overlap.
Very smart.
There were just all these great visual cues you could take out of this, and then it would pop into a schedule. And because of the data that he'd put into the parameters of the family, it would basically tell you what your scan durations were. Like how much time did you need in the field? Because based on the settings that you had, how long it's going to take. So it was this just really fantastic, super simple tool to do scan planning for projects. And so there's a lot of things like that you can do to kind of make your life easier and more predictable.
Yep.
Yeah.
Awesome. So BIM execution plan, step one, and that kind of ties back to the US IBD again, right? Figuring out what you want to do, what you need, communicating that to your scanning team, whether it be an internal team or an outside consultant, whatever the case may be.
Right.
Figure out what you want. Let them know so that you're getting back what you need, as opposed to, hey, I want you to scan this. Okay, I'll scan it. And you come back and you're like, well, that wasn't what I wanted at all. You just said this. You didn't tell me what.
Yeah.
So be clear. That's important. Over capture. You mentioned that one before. That's clean. That's good. Always get more than what you need, because going back out, like you said, is expensive. But then you were talking about registration, and I think in our pre-discussion here, we were talking about 3 different major methods of registration. So why don't you tell me a bit about that?
Yeah, so there's survey-based registration. So some of the scanners, generally the ones I recommend for people, have the ability to actually function like a piece of survey equipment. So you can actually set the scanner up over a point. It has a laser plummet. So if there's a known coordinate point, you can scan on the coordinate system from the get-go while you're on the job site.
Right.
You can also do backsites. You can do resection workflows. So, like a Topcon Trimble, the people that make survey equipment, not surprisingly, have this functionality in their scanners, typically. And so that's really, really useful, because then you don't need a total station to set up survey control. You can actually leverage the scanner for that one piece of equipment. But even for the ones that don't, if you have a total station, somebody else can set control points, and you can usually set a target, like a spherical target or a planar target on it. And later on in the process, you can assign coordinate values to those. But basically, you're using a known coordinate system to establish your scan locations, or some of your scan locations. And that's really important, because usually the job is being built off those known coordinate locations. So even if they're a little wrong, they're actually legally what's being used. So,
and the nice thing is then you're tying your actual building scan to real world coordinates, meaning that when you tie this all together and later on build your Revit model or whatever BIM you're putting together and you export that, it's truly tied to the real world as opposed to A1 level 1.
Yes. Though fortunately you can, of course, extract the A1 level 1 coordinate value for that point pretty easily, and also get the scan in A1 level 1, which is really important for coordination workflows frequently. So, but having it on a known coordinate system lets you very easily make that translation between, the actual geodetic to, a state plane to a local project coordinate system. You can move across those things pretty seamlessly. So
method 1 is known coordinate system.
Yeah, survey control. And so the second one is target. So you don't have to have coordinate values for targets. You can just paste up a whole bunch of targets and then blow and go through the project.
Yep.
And basically the premise is that, if you have 3, or preferably more for redundancy, but if you have 3 targets, there's basically only one geometric fit between scan 1 and scan 2 of those 3 targets. There's
Right.
only one way they can line up. And so if you have enough targets, you kind of just scan through the space. You can be very productive with your scanner
Right.
that way, take 100, 150 scans a day, as opposed to like 60 maybe is probably tops if you're doing survey based.
Right.
And get a lot of scans captured, bring it back into the office. You recognize the targets in the office somewhat automatically,
Right.
and then you get a registration of everything based off those targets. And then the last type is
Oh, wait 1 second now. Let's talk targets real quick. As when you're saying targets at its base level, it's literally a piece of paper of sorts with a target on it and maybe a number to identify which one it is. That's up on a wall or a floor or wherever it is in the building. And there's multiple of them.
It can be. So there's a couple
Right.
types of targets. There's geometric targets, so like spherical targets.
Mhm.
So Faro makes big use, for instance, of these little white spheres.
Right.
Because
Ping
a
pong
sphere,
balls, basically.
yeah, though they're really big ping pong balls.
Right. Right.
It's more like softballs, actually. Softballs
Yeah.
are good,
Yeah.
without the threads. So it's a nice, even, surface. It's the same on all sides. So therefore, no matter what angle you scan it at, you can extract the sphere and fit. So it's a
Right.
geometric-based target. There are what are called, I'm going to use a Leica term because it's what I know, tilt and turn. But there are these targets that it's a special target material. It's reflective. The scanner is usually very good at finding the center for those very accurately. They're a set size, so the scanner knows what to look at,
Right.
just like the spherical targets. But it can be kind of turned and rotated so it's always facing the scanner. But it basically it approximates a crosshair because you get kind of a black quadrant, a black quadrant, and then you have a kind of a reflective quadrant and reflective quadrant. So it finds the center very accurately.
Right.
That I'm sure that looked really great on the screen with all
No,
my
no,
hand
it made
gestures.
perfect sense. Yeah. No, it's all
Great.
good.
And so, and then there's what are called paper or planar targets.
Right.
So those you can literally print out of a black and white printer. You print, either a circle or a square or kind of crosshair pattern, and then same method applies. It just doesn't tilt to face the scanner.
Right.
So
Right.
you get some level of error when you're kind of scanning those at a high level of high angle of instance. But yeah, it's a lot of different ways to do targets.
Excellent. So that was number 2, and then there's number 3, which was
number 3. Yeah, so cloud to cloud, which is the hardest one to explain and the hardest one to troubleshoot. But basically, that's where overlap's important. So different softwares do it different. The algorithms are, very tightly held secrets. Everybody says their algorithm is better than everybody else's algorithm.
And I'm sure they have marketing materials to prove that, from clients who say that it's better.
Yes, absolutely. Fundamentally, what they're looking for are it's a little like photogrammetry in the sense that they're looking for the same features in 2 different scans,
right,
and they're using those features to geometrically line up and match those scans. So the upside is if you have good overlap, it's mathematically the most accurate registration methodology. But in terms of other types of error, you have a greater chance for propagating chain error across a cloud-to-cloud registration than you do with survey, for instance, because your comparison distance, your measurement distances are shorter effectively.
Right.
And it is highly dependent upon the accuracy of the scanner, of course.
Of course.
A noisy, low accuracy scanner, cloud-to-cloud, will be less accurate than with a really expensive, very highly accurate scanner. So there's it's one of those ones that it's just there's a lot of factors that play into how well it works. So it's hard to use as a primary technique. And so the other advice I always tell people with registration is you should use all 3.
Yeah, redundancy is better.
Yeah. Because survey control gives you the ability to map your scans to a real world coordinate system, which is really important. And you don't have to survey control every scan. You just need really a couple. Technically 2 is enough, but 3 to 5 is ideal, or more if you've got a really long kind of a really large project.
Right.
And then targets are a great way to get high productivity out of the scanner. They're easy to troubleshoot. They help you find errors. So, I liberally plaster targets on every job that I scanned, even if I wasn't planning on using them. And then cloud to cloud is a great way to tighten up those registrations locally and make sure that, within a contiguous space that you've got a really, really tight, clear registration.
Excellent.
So, yeah, use all three.
All right. So let's transition a little bit. We've talked about planning to win, basically. Planning out your implementation of potentially leveraging scanning. Some of the things to look for in the field, some of the registration stuff, and of course, there's that USIBD site people can go check out and learn a whole lot more about scanning and what's required and what they want. All too frequently, we get people who ask, like I said earlier, can you scan this? Yep. What do you want? Well, I want you to scan it. Well, that's kind of like people saying, I want you to do BIM. Awesome. What do you want out of this, right? So it's always making sure you know what you need, just like you want your clients to know what they need so you can give them a proper building. But now let's take a look at something else here. So we've been talking so far about Edgewise, primarily, right? The whole taking a scan, bringing it into a BIM solution, and then modeling it.
Right.
But there's another tool that you mentioned that came near the end of your time at Beck, and one of the reasons why you kind of jumped across over to ClearEdge 3D in the first place, I believe, which was this tool called Verity. Tell me what Verity is and what it does.
Yeah, so the short version of the story is about 4 years ago, after I got off of the Kimball job and had been using laser scanning for construction and was starting to use Edgewise for as-built jobs, I started talking to Kevin and Chris and the ClearEdge team and saying, this Edgewise thing's great, but which is what every proud parent likes to hear about their software product.
Of course.
But it'd be really great if you did the same thing, but you compared models that already existed to scans, because we have these coordination models. Stuff gets built in the wrong place. And, that was like my living nightmare on Kimball, spending, man months building these beautiful coordinated models that worked. And then some guy would just go ignore the drawings and route some piece of piping the way he wanted to route it, to hell with what the designers and engineers said, and screw everybody,
Right.
And
suddenly coordination is all out because he prefabbed installed before somebody else got in, and now you're shot. Now you've got other prefab stuff that just doesn't fit.
Yep. So, this was just, oh gosh, it just drove me nuts. So I was like, you guys could solve this problem. And they were like, yeah, okay. Nobody else is telling us that. So, fast forward 3 or 4 years, other people were telling them that. And so they started working on it. And my last kind of project engagement at Beck was testing a central utility plant for a hospital using this new tool called Verity, and just taking the coordinated model, the laser scans, comparing automatically all of this geometry to where it was installed. And it was pretty fascinating because it confirmed a lot of my suspicions.
Yep.
And but it gave me some really actionable data that I could use, which was fantastic. I'd been thinking about moving down to Austin and changing my career path a little bit anyway, and serendipitously things worked out, and I ended up coming on board at ClearEdge about this time last year. Basically taking over management of both products from a software product management standpoint, and trying to bring Verity to market, because there were some things that needed work a year ago, just in terms of the actual user interaction. The technology was fantastic, but it analyzed every piece of geometry in the Navisworks model against every scan in the Navisworks model. So nuts, bolts, all this crazy stuff was getting analyzed, and you had to let it run overnight. And it was like, it was great, but I also didn't like trying to filter through 33,000 things that had been tested, trying to figure about the 30 things I actually gave a crap about. So it was there was some work to do, but that I learned a lot about product management, and it's just a phenomenal team at ClearEdge to work with, and within a couple months, all of that stuff was kind of worked through, and we brought this to market in April of this year, and it's um, the number one customer reaction when we do a beta project with people is usually shock, because I think people just don't understand how often stuff is installed outside of the specified tolerance on projects.
Right, exactly. Now, we did have a question come through from one of our viewers just now. Don was saying that they've been trying to do this for a while. Right now, Don, just to be clear, he's an electrical contractor, and they do a lot of in-slab buried conduit. Very highly precision runs. They scan beforehand, lay it out with points, but then they want to capture this after the fact. And the question is, they have almost no time to set up a terrestrial scan, right? After they've done this. It's rapid, in the field, right? They're laying down conduit, laying down rebar, pouring. So how do they go about the process of doing this? Right? You can't set up a terrestrial scan every single day on every single floor and run this. Is there a better way? And I think I might know the answer. That might be the GeoSlam solution, but is that a way to play with that?
So the challenge with mobile scanning is it's the scanners are noisier. It works great for structure. You're not going to be picking up conduit with a mobile scanner.
Sure.
But what I would say is there's some really great combo units out there. And there's a lot of innovation in this market. So there's going to be new stuff coming into the marketplace, very soon. That's going to be really exciting. But you can go out and buy, Leica, Trimble, Topcon. They all have combo scanner total stations now. So you can actually, the equipment that you're using to lay out the conduit can actually be the equipment that you use to as-built scan the conduit. And so that's actually, I think, the best solution for Donald is, look at getting one of those units, because it's a robotic total station and scanner all in one. And you probably don't need a full dome scan. There's particular areas you're putting the conduit down that you want to capture. And so you could pretty effectively use that to, you lay out where you need to put it, lay it down, and then have the guy who is helping with the layout scan that area. He can start that scan while he goes over and lays out conduit, somewhere else, or lays down the conduit. So you can kind of work it into your work in progress kind of workflow. And so that once you have all the conduit installed, you have the scan, and then you can actually kind of pull out of that and go back and analyze it in something like Verity to make sure that it's all in the right place. Usually when we do betas or kind of technology pilots on projects, we're there one day. We're scanning in the morning, registering, processing over lunch, and then we're analyzing it that afternoon. We usually have results by the end of the day. So it's a pretty quick process if you're not trying to do the whole building at once. If you're just doing one pour, it's actually surprisingly fast.
Yeah. So now the important thing here is, just like with everything, when you're going to add a new part to your workflow, in this case, you're going back and rescanning laid out conduit or whatever your layout is. It takes planning, right? You got to plan this out. You got to know someone's going to be there. It takes a little bit of staffing. It takes budgeting for that, because that's time and money, additional time and money. But there's additional value to be added that, depending on who you are and what your role is, you can market that back to some people. But it takes a plan. You got to have a plan, and you got to know what's going to happen, right? Yep. It doesn't just magically auto scan itself. You gotta figure stuff out there. So
not yet.
Yeah. Not yet, right? Right, exactly. So
but yeah, that's very true.
Yeah.
But yeah, there's there's a lot of these really unique specific workflows, and the thing that I think was really exciting to me about Verity was that it was it's just such a general purpose technology that has so many specific implementations and uses, because it's, if you have the geometry, the hard part about doing extraction from scans is you don't know what it is you're trying to extract. Right. But if you have a coordinated model, you know what you're trying to find and extract. So the problem set is smaller in some ways. The thing that was interesting on that cut project is, some of the trades on that job really did install more or less where they were supposed to. And so, we got highly automated, very quick, easy to analyze and review results for those trades. But two of the trades in particular on that project basically used the drawings as toilet paper. and then didn't bother to update any of those drawings with what they actually put in.
Right.
And so on one of them, I think 90% of the work came back as not found.
Right. Oh my
Because
gosh, as a building maintenance in the future, if this is like a BIM, turnover, that is a nightmare maintenance issue.
Oh, I know.
Oh
And
man.
so, well, and it's a hospital, so it's like,
Oh
there are
gosh.
some like life critical, mission critical valves and
Yeah.
things that you need to know what valve A does, because it could really mess something up if you
Yeah.
turn the wrong valve. So I mean, it's like, it's serious stuff, and
What
it
it
was
does and where it is, for goodness sake.
yeah. And so, well, yeah, because you don't know where it is, you don't know what it does.
Right. Well, yeah.
You got to know the first to get the second. But yeah, it was we knew we kind of had this gut feel that stuff had not been put in, but the big stuff, the stuff that of course gets kind of checked in QA/QC'd on the job,
Right.
that was close to the right place. But
Right.
it was all the little stuff that was, and by when I mean little in this case, I meant like stuff under 6 inches,
Sure.
so not that little.
Right. Right. Still
was
significant.
was just field routed, and so it
Yeah.
was and not updated in an as-built, and so it was again we knew we needed to solve the problem. We found a way as a contractor to solve that problem for our client and meet our obligation to do so. But it was gosh, it would have been a whole lot harder to solve that problem without that tool.
Right. I
So,
gotta imagine the QA/QC, the whole commissioning process in all trades has got to be immensely sped up by just scan and then commission in an office instead of commissioning by walking around with a clipboard or something. Much faster.
well, and the kind of thing that's such a problem with the industry, and this is maybe jumping to my soapbox, but
We'll get there very soon.
yeah, it's just spot check. The industry has been built upon this kind of spot checking methodology
Right.
as a QA/QC program,
Check
and
the 1%.
there's some kind of requirements for it to actually be spot checking, and we don't bother to follow those requirements. So we aren't even really doing good spot checking, and but it's kind of the system we have, and everybody's used to it, and it's just a lot of fundamental flaws in that system. But I'll save that for my soapbox.
So let's get closer to that. Let's talk about just technology in general. We talked about Logitech Flow early on in the show as a newish technology, but what in the world of BIM is exciting to you that's coming down the line? I mean, there's all kinds of new tech. What to you is like the most compelling thing, or one of the most compelling things? It might be multiple things.
Yeah, so a buddy of mine has this thing he likes to do in slideshows called tool versus toy, and
Right.
he shows all these different things, and he has the audience call out whether it's a tool or a toy, the fun if it's a conceit because he knows what his answer is for all of them, of
Right.
course,
Of course.
and every one of them is in his opinion a tool. And one of the ones that I love is he has this scooter.
Okay.
And so this is, I think it's John. Anyway, John Russo with Arc Systems. This scooter, and it's a little electric scooter, and it's like it's a kid's toy.
Sure.
But when
Like
you're
a razor.
scanning, yeah, when you're well, this one's motored.
Right.
Has a little motor in it, so
Yeah.
yeah, it moves you around pretty quickly. But when you're scanning large flat work, walking around from survey point to survey point, carrying a target on your back with a tripod and all this other stuff, it takes a stupid amount of time walking.
Right.
And so like for him, this is like he literally has these for his company and his people.
Nice.
They use these. They scooter around on these flat work jobs because it makes them much more efficient.
Gotta imagine
And-
airports. I mean, think about an airport. Good
Oh.
Lord, scanning a terminal? Good
Yeah.
goodness.
Yeah, so I mean it's one of these funny things, right? So within that, I know a lot of people think that VR and AR is a toy.
Right.
But I'm just super excited about both. Right as I was leaving Beck, we got some new people in, and we kind of reorganized some things, and we're starting to really investigate VR as a design tool, not as a selling tool or something else, but just a design tool.
Right.
Leveraging things like Inkscape or Twinmotion to put the designer in the space, in perspective,
visualize. Yeah.
and just understand what it was they were creating. And it was it was an incredibly empowering tool.
Yeah.
And for me, that's really exciting as from a design background. But AR is way more exciting to me because, we so many of the challenges in the AEC industry that we face are as a result of this kind of continuous, data buildup and degradation cycle that we have, right?
Yep.
Where it's like we pump all this data into, our early analysis tools, and then we dump to drawings and move to another platform. All the data into our BIM, and then we dump to drawings and we move to another platform. And then it's just like, and then we do it all in the fabrication model, and then we dump to drawings. And then we have all this fabricated stuff show up on the job site, and then we assemble it all together off of drawings. It's oh my God, it's...
And you generate an as-built model and you dump it to drawings.
And you dump it to drawings. And there's just so much waste and lost productivity in that cycle. And, I think there are a lot of really promising existing implementable today technologies for eliminating those data troughs in most of the front end workflow. It's really easy to take your analysis package into your BIM package, into, even into kind of your high level fabrication and coordination. But the tool to kind of eliminate the last kind of couple of data troughs out on the job site, it's AR.
It is.
It's allowing people to leverage the model to help them build the building on the fly, real time. And I think once we really have implementable on the job site AR solutions, that it's really going to free, I think, everybody upstream in that chain. It's going to free us up to just get away
more info in a more meaningful way, and then just leverage that.
2D drawings and just be able to actually, VR helps us do that on the design side with clients too. But I mean, AR, I think, is going to be transformational.
Let's reference back to the question Don was asking, right? Don was saying after he lays out his conduit, their teams in the field do this, they pour concrete over it. Well, now 2 years later, you need to go out in the field and figure out, where can I drill a hole to run this new run of name your feature that you're running through the concrete. And you don't want to be drilling through electrical conduit, man. That's just not a good idea. So if I could put on a AR set, know where I am in the model, know where I'm in the building, look at the floor and go, I see through the floor with X-ray vision exactly where that conduit is. That is amazing.
What you're saying is absolutely shocking.
Right? I'm just charged up about this, man.
Yeah. Oh. And the puns resume. It's precisely those use cases in operation that are valid, but just, gosh, if this is, one of the other takeaways from using Verity on some large jobs with some, major general contractors now, we've got a pretty impressive client list implementing this technology on job sites. Is they do it early on, and then all of a sudden people realize they actually do need to install the work the way the drawings show.
Right.
And the funny thing is, they get really frustrated by it at first until they realize that the largest pain in their butt on a job site, if you talk to almost any sub, is as-built. They hate it. And if you actually just install the work the way it's drawn, you don't have to do anything.
There isn't an as-built because it's already built as designed, so your as-built is built.
And it's just this, it's this, it's almost like a Yogi Berra moment. Right? It's like, how is this not obvious? But it's not. It's just not inherently obvious because it's not that, hasn't necessarily been that easy. But it's, people start, going to the effort of getting it put in the way it is in the drawings because they know you're actually checking everything as opposed to just checking, non-random 5%.
Right.
And then it's like, they get done with an area and it's all pretty darn close. And then they're like, oh, wait, here's our as-built.
Yeah. Oh, my job is done now. I did my job and I did my job.
I could like move on to the next area and not have to worry about when am I
Right.
going to have time to come back and as-built the thing I just
Right.
did before they cover it up with something. It's so there are benefits,
Yeah.
kind of across the chain for these things, but AR makes that so easy,
Yeah.
because you can actually see where it's supposed to be overlaid in the real world and just put it in the right place the first time without having to look at drawings to figure it out. So I mean,
Yep.
there's all sorts of things, but reality capture, of course, is a key enabler to augmented reality, because you have to be able to document reality and digitize it in
Yep.
order to be able to figure out where you are and then
Yep.
reproject stuff that's not there yet, and so, or that's invisible. And so, just all the different all the different advances in reality capture right now are also super exciting. And there's, again, the selfish reason that that's also an enabling technology for
Right.
clear edge,
Right.
and the things we can do with that data is exciting for for my own professional reasons.
Exactly.
And then machine learning.
Machine learning. All right, well,
So
we're running quite late today, and that's fantastic. I'm all about running overtime, no big deal. But let's get to the next segment here, and this is one of my favorite segments in all these shows. Kelly, you and I talked ahead of time that I let my guests have a 2-minute soapbox to talk about whatever, and I think you may have alluded to yours a little earlier. But let's talk about whatever your topic is you want to share with the world. Your 2-minute soapbox on the clock, ready, go.
yeah, so there's this wonderful thing called spot checking, and it was invented a really long time ago in the manufacturing world, probably before that, but it was applied by the manufacturing world as a mechanism to control quality on the assembly line. And the fundamental basis for spot checking is that you randomly sample and check work. That way, the people doing the work don't know what's going to be checked.
Right.
So they're incentivized to do everything correctly.
Right.
And this is kind of a core fundamental requirement for spot checking to be functional as a quality control mechanism. So my pet peeve, my soapbox, is that in the construction industry, that's not actually what we do. We like to call what we do spot checking, but what we actually do is check stuff we're scared about.
Right.
And the problem is the trades know what we're scared about. So when you have a tradesman that's putting in work and they know that you're really scared about this 12-inch chilled water main, but you don't really care about the 6-inch chilled water pipes that are servicing different equipment, you make sure that that 12-inch or 14-inch main's in the right place. And the other stuff you just put wherever the heck you want, because nobody's going to check it.
Yep.
And this is what happens on construction sites every day, is the stuff that the soups, the stuff that the engineers, the stuff that the owner is worried about and everybody knows is going to get checked, gets done right. And then all the other stuff is what comes up and bites you in the butt when it's done wrong. And this happens over and over and over and over again. And that's why, a lot of the surveys say that this is between 5 and 12% of the cost of the project is lost to rework as a result of these kinds of issues. That's about $480 billion annually.
Oh yeah.
480 billion annually is lost because of this, and that's pretty shoddy quality control. And so we're there because we didn't have a better way to do it 10 years ago, 20 years ago, 50 years ago. And it'd be nice if we would just go random. That would be a little bit better, but
Who's got time for random?
Who's got time for random? But I also don't think we really understand random very well in a mathematical sense. I don't have a website. I don't understand it really well.
Need to incorporate some machine learning into that.
Yeah, but that's the beauty of what Verity can do, because the other alternatives, you just actually check all the work, and you use automation and computer vision and machine learning and things like that to actually check everything. And then it doesn't have to be a random sample. You can actually have a modern quality control mechanism in place on a job site. So I know it's a self-serving soapbox, but it's also something that just drives me absolutely nuts when I'm out on a job site and somebody says, "Yeah, we're doing spot checking." I'm like, "Oh, really?
Oh, really?
What's your random sampling protocol?" Huh?
My random sampling protocol is whatever I feel is important to me at the time. Yeah.
So it's like, oh, well, on my last job, We had a really big problem with slab edges. Okay, so you're not random sampling.
Right, you're checking the slab edges.
Are you also checking your penetrations? Are you also checking your floor flatness? No, you're not. Okay, well, I bet you will find a penetration or floor flatness bust that's at least a $20,000 problem. And so, you know, and our software costs, you know, a quarter of that. So
exactly.
Yeah, so that's
all
my
right.
soapbox.
Well, Kelly, thank you so much for visiting with us today. I really appreciate your time and talking about laser scanning, as-built validation, as-built modeling, all that jazz. It's an interesting topic that many of us are digging deeply into. So I appreciate your time. Before we jump off today, guys, you guys all know that Autodesk University is coming up in about 2 weeks, about a week and a half actually at this point.
And BIM Forum is next week if you happen to be in the Dallas area. So
yeah, BIM Forum as well. So lots of events coming up. Our next scheduled, I'll put this in air quotes, scheduled BIM broadcast will not be happening on the Friday that it is scheduled. That is the 17th. Won't be happening then. We're going to be doing some live streaming directly while at AU, talking to different people on the convention floor, talking to teachers, talking to all kinds of people. So if you subscribe to our channel, definitely make sure that you subscribe, but also hit the little bell next to the subscribe icon, because when you do that, when we go live and we start to stream, it'll automatically pop up that we are streaming, and then you'll be notified and be like, oh, I can watch whatever this cool thing is. Or, of course, if you're subscribed, you can always come back and look at it later and watch the recording, because it's all being recorded as well. That said, the next major event that's coming up that I want to put into your ears as a bug is going to be Midwest University here, okay? Midwest University is a Midwest, obviously Midwest University. It's a Midwest event. It's up here in Minnesota. It's in March. You can see March 21st, 22nd. The reason why I'm bringing this up right now is we are about to close the speaker invites, the speaker submissions. And that is important because as a speaker at Midwest U, you get free entry for yourself. If you end up getting 2 classes accepted, you get a little bonus for teaching 2 classes. So I strongly encourage you all to, if you are interested in going to Midwest U, and you should be, it's basically a localized AU / built conference in the Midwest, high quality teachers, be in that teacher set and get a free entry, right? That's fantastic. So I know that right now we are actively seeking MEP classes, we are actively seeking civil classes, and we are actively seeking structural classes. So if you're in one of those disciplines, by all means submit. And if you're not, and you're like, well, I want to do something on laser scanning, fantastic. Submit a class in laser scanning. We want classes of all variations. So don't be shy. That said, you know what, guys? We thank you all for joining us today. Really appreciate your time and joining us live. Those of you catching this on the recording, don't forget to subscribe. You can catch us live and interact with us in the show like Don did earlier today. We always enjoy your feedback, your live interactions, and it makes the show more interesting. So, and also, if you have topics you want us to talk about, let us know. Comment in the comment section below, and tell us, hey, we want you to talk about such and such, or talk to so and so. Let us know who that is. We're here about making sure you get the information that you want. All right, guys, thank you all, and have a fantastic week.